Okay, good morning class. So you guys had homework? Morning. This was on page 51. Your homework was that you needed to rewrite this in your books, not so? Okay. Didn't have chance to explain this yet, so let's do it now. So we're busy with logarithms, no? Morning. Morning, Simon. So now we're looking at logarithms and logarithmic functions. Logarithmic functions. Okay. So here we're given the definition of logarithms. Okay. So log of x base y. Now when you write this in your books, then you write it as log x base a. Can you see that? So that's log x base a. Do not write it, and this is your lines, as log a base b. So that means, and then you are trying to say that is log a base b. Try and write it lower down so that the examiner knows that is the subscript, basically, in that position. Because if you write it as log b base a, then to us it looks like it is log a to the exponent b. Can you see that, people? So that is log a to the exponent b. So if you want the base to be a, then you say log x base a. You write it like that. Okay, you guys got it? Let's take this off. So log x base a is equal to y if and only if x is equal to a to the y. So logs is basically another form of writing exponents. So there's a direct link between logs and exponents. You guys understand? Alright. So where a is greater than 0, which means to say a is positive, and x is greater than 0, which means to say x is positive and a is not equal to 1. That's the condition. This means that the logarithm or a logarithm, you hear me say log all the time, okay? So you'll drop the word logarithms. It is log. It's closely related to exponents, okay, as indicated already. Special log values. This is very important, that log of 1 base a, log of 1 to any base, provided that it adheres to that condition, is equal to 0. Why? Because a to the 0 is 1. Let's speak about the format now. And log a base a, when the number and the base is the same, it will always be equal to 1. Okay. So here we got log of 16 base 2 is equal to 4. So we say log of 16 base 2 is equal to 4. Okay? Because you see here this base remains the base. 2 to the 4 is equal to 16. Can you see that, people? Yes? Let's look at the next one. Now with you again. We look at log 1 over 125 base 5 is equal to negative 3.
Mr. Bodine?
Yes, miss?
Got 12 C's with you?
No, miss. This is 12. A and B. Yes.
A and B?
Yes, miss.
Okay, sorry.
Okay. So log 1 over 125 base 5 is equal to negative 3. In exponential form, you see, this is the base, not so? The base remains the base. So that would be 5 to the negative 3 is equal to 1 over 125. Can you see that? So coming back to your question with regards to this one, let's do it again. So log 16 base 2 is equal to 4. So that 4 goes as the exponent on this base. So it's 2 squared and 2 to the power 4, which is then equal to 16. Make sense? Right. The next one, log of 100 is equal to 2. Now, since there's no base here, you see there's no base here. If there's no base, it is given to be a 10. Can you see that, people? If there's no base, the base will be a 10. Like, if we got the square root, if there's no number here, what number belongs there? A 2. You got x here, what would that index be on that x, or the exponent be on that x? 1. What the coefficient will be? 1, and it will be over 1. So that's like a given. Not so? So if you write log 10, and there's no base here, then what is the base? 10. And log 10 base 10 is equal to what? 1. Where are we getting that from? From there. If log of the number and the base is the same, it will always be 1. You guys got it? Okay. Just stop me if we've lost you somewhere. Huh? Don't tell me I've lost you in grade 11 already. Right. So if we got log 100 equals 2, then there's no base, there's a 10 here as I have indicated, which means to say that 10 squared is equal to 100. All okay with that? Log laws, very important here. These laws you must familiarize yourselves with. That log A times B base C. Log AB base C is equal to log A base C plus log B base C. This is log of the product is equal to the sum of the logs. Can you see that, people? Log of the product is equal to the sum of the logs. So if you look at this example here, we've got log 2 base 6 plus log 18 base 2 plus. Okay, only that. Okay. You see here the bases are all the same here. Very important to note. Are these bases the same? No. It should have been the same. I'm supposed to have it written as 16. Are the bases the same? Yes. So this is the sum of the logs, not so? So that will equal to log of the product, not so? So that number is A, which is 2, and B is 18, so it's going to be 2 times 18 base 6. What is 2 times 18? 36. So let's say log 36 base 6. Okay, I think I missed the log glue. But anyway, I see the log glue is coming down later. But now 36 can be written as what? Now we'll try and write it as the same as this base here. If you're going to punch it in the calculator and factorize it, you're going to get 6 to the 2 squared times 3 squared. Not so. But the base here is 6. So I'll try and write the number and the base the same. Okay. So you've got log 36 can be written as what? 6 squared. Not so. Now coming to the third law of exponents, you see that exponent on that A is P, and you can write that in front as well. So that if you got, this is now the third law, if you got log A to the exponent P base C, this exponent can be written in front. Okay, as P log A base C. Okay. So I'm going to apply that law here. That exponent can be written in front. So that's going to be 2 log 6 by 6. Now what is log 6 by 6? 1. So 2 times 1 is 2. Right, you guys understand? Okay, just need to play around with this. Now these log laws can be proven, people. You can prove all those laws and all of those things, but you don't need to prove it. Okay? First university, they prove this for you. Okay? For now, we're just doing a little application of it. We don't go too much in depth in this. In the past, this used to be a section, a nice section in the higher grade syllabus. Okay? But they took it out for some reason or other. Every time I go to maths meetings, I ask them to take financial maths out and put this in. Okay? Why? Because this is exciting. Okay? Logs is exciting. Number 2. This in absolute value graphs. They can put those two in. Which is also okay. Used to be in the old syllabus. And linear programming was also nice. Right, number 2. Log law 2. If we say log of the quotient is equal to the difference of the logs. Here we dividing, so we subtracting. Here we multiplied, so we added. Can you see that, people? So let's go with the example on log 2. On example 2, so log 12 by 6 minus log 2 by 6. When we subtract, what we do with the numbers? We divide. Whichever number is first, you put on top as a numerator. So this will be log 12 divided by 2 base 6. So that's going to be log 12 divided by 2, 6. And 6 by 6 is? Let's look at log law 3. Third log law, we spoke about that already. That log a to the exponent b by c can be written as p log a by c. So let's look at the example. We got log 81 base 3. Now 81 can be written as what? Can be written as 3 to the exponent 4. Why do you think I wanted to write it as 3 and not 9 squared? Because we want the base and the number to be the same. Why do we want it the same? Because if it is the same, it will be equal to 1. Okay. This is normally, the sum normally reads, simplify without using a calculator. And you must show these steps that I'm showing you. Okay. So where does this 4 go? Different. So that will be 4 log 3 base 3. So what's log 3 base 3? 1. So that the answer will be. Okay. You all okay with that? Let's look at number 4. You got log A.
My apologies for
base
the
B.
interruption. Mr. Simpson, can you please buzz the office immediately? Mr. Simpson, please buzz the office immediately.
Log A base B. Now, there's a log law. The fourth law says that log A base B can be written as log A with a different base C over log B with the same base as the numerator C. Okay. You see this base here? It must be the same. If you do. Okay. So let's look at the example pertaining this here. We got log 8 base 4. Now you see I can't write the base and the number in the same value. Not so. Why? Because the base is going to have an exponent and the number is going to have an exponent. So we apply this rule here, and this will simply be log 8 over log 4. Now I could have made that base any base. I could have made it log 8 base 3 over log 4 base 3, or log 8 base 2 over log 4 base 2. But I don't need it. So what is this base here now? 10. So in other words, it's log 8 base 10 over log 4 base 10. Okay. So 8 can be written as what? 2 to the power 3 over log 2 to the power 2. So what can happen now? What can happen now? you can bring the exponent forward it. Okay? 3 goes there, 3 goes there. So what will this be now? 3 log 2 over 2 log 2. So what's going to happen now? Log 2's cancel. So the answer is 3 over 2. Okay, any confusion? Alright. So let's look at the examples, the worked examples. People, definitely you'd have to watch this video again over the weekend, okay? Because that's something brand new to you. And you need to practice it, okay? For those of you who are going to write the NBTs and all of those things, it's a nice skill to understand how to do, okay?
Mr. Bodine?
Yes, miss?
Need the grade 12s in the hall, please, sir.
All the grade 12s?
Yes.
Okay. Okay, the agreement was not to send you guys though during the briefing this morning. But go, let's see what they want. What I'm going to do is I'm going to do the examples in this video. You guys can watch it later. Okay? Your homework will be exercise 2. I will go into exponential functions and the inverses as well. So please watch the video. Okay, this is the last part of the section of work anyway. I don't know. This is very important for Monday's lesson, okay? Come girls. Bye. Enjoy the weekend. Close the door please. Thank you. Okay, so at this point it says use the definition of logs to convert logarithms to the exponential form and exponents to logarithmic form. Okay. So if looking at number 1.1, they asked you to write these equations in exponential form and solve for x. Okay, so coming back to the condition, you must remember that this x, it has to be positive. Okay. So if we're going to look in general, if we got log a base b is equal to c, then this can be written as in exponential form, b to the exponent c is equal to a. Remember that base remains the base, and vice versa. B to the exponent c is equal to a can be written as log a base b is equal to c. We see, or your exponent is the subject of the formula. Okay, so if we convert back, okay, to exponential form, then that will be x squared is equal to 81. So x squared is equal to 81. So what's going to happen at this point is that if x squared is equal to 81, normally if we introduce square root, we must not forget plus minus. Okay. However, so that is equal, so x equal to plus minus 9. But the condition that is given to us that number, that x, in this case your a, your b, your a and your c will always be positive. Okay? No, your c don't have to be positive, sorry. Your a and your b has to be positive. Okay? So, x can only be positive 9. It can't be negative 9. Okay? So x is equal to 9 is the solution. Okay? Let's carry on. In 1.2, we got log x base 5 is equal to negative 2. Again, if you change this to exponential form, it's 5 to the negative 2 is equal to x. So therefore, x is equal to 1 over 25. Okay, that is fairly simple, eh? Okay, come inside. Okay. So in 1.3 we are told you got log x squared plus 2x base 2 is equal to 3. Again, to convert from log to exponential form, that 3 goes on to the 2, and 2x squared plus x squared plus 2x will be written on the other side of the equal sign. So here I got 2 cubed is equal to x squared plus 2x. Okay. So 2 cubed is 8. So 8 is equal to x squared plus 2x. So to bring the 8 over, we will have 0 is equal to x squared plus 2x minus 8. So this is now a trinomial here. We need to solve the trinomial. So that's 0, it's x and x, 4 and 2, positive 4 and minus 2. Okay. You could have used the quadratic formula as well if you're a bit shaky when it comes to factorization, or you can use that silver calculator to factorize it for you. So in other words, therefore x is equal to negative 4 or x is equal to 2. But you're going to say, yes, is it fine for x to be negative 4? Let's check. We put negative 4 in here, it's going to be 16 minus 8. 16 minus 8 is 8. Log 2 base 2 is 3, so that negative 4 is correct. Remember that this bracket here, that cannot be negative. Okay, as long as that is not negative, it should work. Okay. So x equal to negative 4, x equal to 2 then. Okay. Let's go to the next part of the sum of the example in number 2. In number 2, we are told to write the equations in log form and solve for x. Correct to two decimal places when necessary. Okay. So, if you're looking at 5 to the x is equal to 100, we know that a to the c is equal to b, if that's the case. C, which is the exponent, will be the subject of the formula. So c is equal to log b, and the base, which is a, remain the base in log form. And you just check if it is correct. So a to the exponent c is b, yes, and that is correct. Okay. So x, as you can see, is the exponent. So that will be the subject of the formula. So we'll say x is equal to log 100 base 5. Now there's no way that I can write 100 as a base of 5. Okay, because that would be 2 times 5 squared. So that's not going to work. This is the reason why they tell you it needs to be in two decimal places. So that would simply be, you put on your calculator. Now there's two log buttons on your calculator. You see this one here? That one says that is log of a number base 10. Okay? However, the one we are interested in is this one here. Okay? Which says, press that. So it will be base 5, log 100, base 5. Which gives you 2,86. So that x is equal to 2,86. Okay. That is one way of doing it. Or, if you got 5 to the x is equal to 100, and I now introduce log both sides. When I introduce log both sides, remember log is a function, as sine and cos and tan are. So log means nothing without a number in front of it. To the x is equal to, when we do the function one side, I must do it on the other side as well. So what I do is I bring that x forward. I use the third law of logs. So you got x log 5 is equal to log 100 divided by log 5 both sides. That cancels. So x is equal to, and you put on a calculator, you got log, you see no base, so the base is 10. Don't have to put that in. Log 100 over log 5. It gives you 2,86 as I previously had as well. Okay. Take this off. Question 1.2. In question 1.2 now, we have 25 is equal to 10 times 1.5x. So 25 is equal to 10 times 1.5x to the exponent x. So you could have introduced logs immediately. Okay, I'll do both ways, but I'm going to do the easier way first, which I think is the easier way. You can decide once you have seen both methods which way is easier. So firstly, we want to get it in this form here. A number to the exponent is equal to b. So, to get it in that form, I must first get rid of the 10. So I divide by 10 both sides. That's gone. So it's 1.5 raised to the x is equal to 2,5. Okay, 1.5 raised to the power x is equal to 2.5. Okay, I can do as I did in the second case for the first example. I can log both sides, or I'm just going to write it straight into this log form here. So remember, the exponent will be the subject of the formula. So x is equal to log 2.5 base 1.5. Okay, so that is going to be log 2.5 base 1.5. Still comma 2, 6. So x is equal to, okay, that's one. Or, if you're going to go to 25 is equal to 10 into 1.5 raised to the x. I could have logged both sides initially. So I say log 25 is equal to log 10 times 1.5 raised to the x. Now remember, the first law of log says log of the product is equal to the sum of the logs. So it's going to be log 25 is equal to, now I break this number up. It's going to be log 10 plus log 1.5x. Now log 10 base 10, that is 1. Or I could have left it as log 10. So that is a 1, I'm bringing this over the equal sign. So that's going to be log 25 minus 1 equals log 1.5. Also I'm bringing that x forward. Okay? So that will simply be x log 1.5. To isolate the x, we get x on its own. I divide by log 1.5 both sides. Okay, so that's gone. So therefore x is equal to, on your calculator you now say fraction log 25 minus 1 over log 1.5. 2 comma 26 as we initially. So whichever way you feel is more easier for you, I'm sure it's the first one you apply. Okay. Let's look at 1.3. Again, we can apply log straight over. Or, I'll do both methods again. Or we're going to get it in this form first. So I divide by 2 first. So we've got 3 to the x minus 3 is equal to 6. You see the base, so it is in that form now. So the exponent is the subject of the formula, in this case is x minus 3, is equal to log 6, base remains the base, 3. How do we isolate the x? We get x on its own, but then negative 3 over. So x is equal to log 6 base 3 plus 3. Let's put that in the calculator. Again, we're going to use that one because we have a base of 3 there. So it's base 3, log 6 base 3 plus 3. Let's give you 4,63. So x is equal to 4,63. Otherwise, we applied logs from the beginning. So it's 2 times 3 to the x minus 3 is equal to 12. Do I introduce logs both sides? Simply reads log 2 times 3x minus 3 is equal to log 12. Okay? So what we're going to do is we're going to break this up. So it's going to be log 2 plus, remember log of the product is equal to the sum of the logs. Log 3 to the exponent x minus 3 is equal to log 12. So this log 2 goes over the equal sign. That goes forward. So what I will have now is x minus 3 log 3 is equal to log 12 minus log 2. How do we get rid of the log? Divided by log 3 both sides. That's gone. And I take that negative 3 over afterwards. So therefore x is equal to log 12 minus log 2 over log 3 plus 3. Okay. That is simply, with no base, I use the other one. So it's going to be log 12 minus log 2 over log 3. Come inside.
Oh, so I just can't become it. I just can't fill it all this back and see sometimes.
You're in the wall.
Okay, thank you.
Okay, pleasure. 4,63. So again, I think the first method is fairly simple enough just to first get it in that form and then change it to logs. Okay. So at this point, your homework is going to be exercise 2. You do the first. Okay, you can do the whole exercise. Okay, exercise on page 52. Exercise 2 on page 52. Okay. Exercise 2, page 52. If you're in our next lesson, you can just let me know what the issues are, and then we will have a look at that thing. So at this point, you pause the video and you do exercise 2. Okay. Now we're looking at exponential functions and their inverses. Okay. Now at this point you can write this down in your maths books, in your notebooks. Explain this to you now. Okay, so we're looking at example 1 on page 52. Okay, firstly the explanation to it. We are told on page 52 the exponential function and the inverses. In topic 2 you have learned that to find the inverse of a function you swap x and y and rewrite y in terms of x. For all exponential functions, if f of x is equal to y to the x where a is greater than 0 and a is less not equal to 1, then for f to the minus 1 of x equals a to the y. And f of the inverse function of x, so that's the inverse function of f, which is equal to y, which is equal to log x base a. As you know, that is we make that the subject of the formula. The base remains the base, so it's log x base a. Okay. Then if f of x equal to 1 over a raised to the x, where a is between 0 and 1, then the inverse function, or f to the minus 1, remember we did that in our previous lesson, that x is equal to 1 over a to the 1 over a all raised to the power y, and the inverse function of x, or f to the minus 1 of x, is equal to y, which is equal to log x base a. So something I want to highlight at this point is that I could have rewritten that as x is equal to a to the minus 1, which is a to the minus 1. That could have been written as negative y is the subject of the formula, log x base a. So if there's we divide both sides by negative, so that will be negative log x base a. Okay, that is also the equation of the inverse function. That there, that is the same. Okay. Normally, when we do our past papers on this, we'll see when they do a transformation question, that is basically the hidden part that we learners always get a bit confused about. Okay. So we're looking at the worked example 1 on page 52. And while worked example 1 on page 52, they ask you to draw the graphs of f of x equals 2 raised to the x and its inverse function on the same set of axes. Write down the inverse function in the form. Now, we have done this graph before, okay, many times before. So what they did was they drew up a table and they came and they drew the inverse function, remember by swapping x and y around, and then you'll get this graph here. Okay. There's something you need to consider here to find the equation of the inverse function. We'll speak about that now. But of course, we're not going to always draw a table like this. Okay? So the easiest way for this section of work to draw these graphs, I draw a little table. And the values I use for this table is negative 1, 0, and 1. I use negative 1, 0, and 1. So what is the corresponding y value for f of x? So that would simply be 2 to the negative 1, which is half. 2 to the 0, which is 1. 2 to the 1, which is 2. So if I plot that on a system of axes, it is negative 1, 0, and 1. That will be 1 and 2 there, of course. That's your y. So if x is negative 1, y is half. If x is 1, y is... If x is 0, y is 1. If x is 1, y is 2. So there is a graph coming through. And this is your function. If you now look at the inverse function, remember what do we do for the inverse function? We interchange x and y. Not so? So if we take these points into account here, which is negative 1 and a half, it becomes half and negative 1. So for the inverse function, if I have to draw the table for this, that's your x and the y, negative 1, 0, 1, half, 1 and 2. So we're just literally interchanging x and y. So if x is half, y is 1. Remember that is 1. If x is half, y is negative 1. That's not the right thing. X is half, y is negative 1. If x is 1, y is 0. If x is 2, y is 1. So there's that graph coming through now. And this is the equation of the inverse function. Again, when we draw the function and the inverse function, we always draw in the graph or the line, y is equal to x. And as you can see here, if I fold this graph close in the line y is equal to x, they will fall exactly onto each other. Alright. Then in question 2, it says write down the inverse of f of x in the form of y equals. So if you need to look at that question 2. For the inverse function, remember, what did we say? We replace the f of x with the y. So y is equal to, let's change it to purple here. Y is equal to 2 to the x. Okay. So what do we do for the inverse function? Interchange x and y. So x is equal to 2 to the y. Okay. So coming back to the log law, remember this is the exponent here. Okay? That's the exponent. So that can be written, that will be now the subject of the formula. So y is equal to log x, base remains the base, log x base 2. Is that inverse a function? Is this inverse graph a function? Okay, you guys are probably still not here. Is the inverse a function? Yes. Why is it a function? Passes the vertical line like this. Okay. A couple of things I wanted you to note at this point is that the graphs are reflected in the line y is equal to x. We know that. It's your inverse function. The range of this, right? Let's talk about the range and the domain of this graph. This was not asked. I will answer it anyway. So the domain of f and the range of f. So what is the domain of the function? This going to negative infinity, positive infinity. So that's the case. So what is your domain? X is an element of all real numbers. What is the range? Does this graph exist at negative infinity?
Yes.
The g of f of x? No. Where does it start existing at? 0 onwards. So y is greater than 0. If I look at the domain of the inverse function and the range of the inverse function, does this graph, the inverse function, does that graph exist at negative infinity? No. It only starts existing from 0 onwards. So that is y is greater than 0. The range, does this graph go to negative infinity? Yes. Positive infinity? Yes. So it is actually x is greater than 0. No, not y. And your range, y is an element of all real numbers. And there you can see clearly, your domain became the range, and the range basically became the domain. Let's look at worked example 2. Okay, I need the space here. Okay, so in worked example 2, on page 53, we are told given f of x equals 3 to the x. Write down the equation of these graphs in the form. So in 1.1, they want g of x is a reflection of f in the y-axis. Something reflected in the y-axis, what happens? X becomes negative. So f of x becomes negative, so it's minus f of x equal 3 to the minus x. We could have just replaced this also simply with a y if you like. So therefore, g of x is equal to that thing, or 1 over 3 raised to the x. Either one would be correct. 1.2. H is a reflection of f in the x-axis. So if something is reflected in the x-axis, what happens? Y becomes negative. So in other words, that would be negative y is equal to 3 to the x divided by negative both sides. So y is equal to minus 3 to the x. Okay? And this is the equation of h of x. 1.3. In 1.3, the inverse function of f. What do you do for the inverse function? We first rewrite f of x as a y. For the inverse function, we interchange x and y. So x equal to 3 to the y. Make y the subject of the formula. So y is equal to log x base 3. And that is your inverse function. 1.4. They ask you for the inverse function of g. G of x is this graph here in 1.1. So y is equal to 3 to the minus x. If I take the inverse function, I interchange x and y. So minus y is equal to 3 to the x. No. Minus x is equal to 3 to the y. Okay? Make y the subject of the formula. So y is equal to log minus x base 3. But here remember that x has to be less than 0. No? X has to be negative. No, I made a mistake. You must just interchange x and y, not the negative. So that is x is equal to 3 to the minus 1. There we go. So make y the subject of the formula. So negative y is equal to log x base 3, which is y is equal to negative log x base 3, which is the inverse function of g of x. Okay? Or if I had gone with the second, with this here, then we have y is equal to 1 over 3 raised to the x. Inverse function, we interchange x and y. So x is equal to a third to the y. So y is equal to log x base a third. And as I've indicated, those two are equal there. Then it says draw the graphs of the function and the inverse function. I'm sure you can do that now. Just follow the other steps that I showed you. And use your graph to determine the value for x. I'll answer these questions in this video now. You guys can leave. I'm sure your teacher is waiting for you already. Okay. Right, so I just need to wrap this up quickly. So in number 2, it says draw the graph of f of x and the inverse on the same set of axes, showing all intercepts with the axis. So as I indicated before, to draw the f of x graph is going to be easier just to fill in these values. So it's negative 1, 0 and 1. So 3 to the negative 1 is a third, 3 to the 0 is 1, 3 to the 1 is 3. So if I draw that graph, okay, is negative 1, 0 and 1, 1, 2, 3. Okay, so x is negative 1, so it's a third. 0 will give you 1, and 1 will give you 3. Okay, the graph is not drawn to scale, but that's basically what f of x would look like. So what do I do for the inverse function? I basically interchange x and y. So x becomes y and y becomes x. I'm just going to draw here inverse function. Or you could have just written f of f to the minus 1. X and y, so it's minus 1, 0 and 1. it's a third, 1 and 3. So negative, so it's a third, is going to be negative 1. X is 1, y is 0, and 3, then 1. Again, the x-axis is an asymptote for f of x, and the inverse function, the y, is an asymptote. Okay. Whenever we draw these lines, we always fill in the line, or draw in the line, y is equal to x. Why? Because the inverse function is the study of the graph in that axis, the reflection of that graph in that axis. Then it says, in number 3, it says, use a graph to determine the value or the values of x for which f of x times f to the minus 1 of x is less than or equal to 0. So, for f of x times the inverse function to be less than 0, or in other words, negative, the only way we're going to get something resulting in a negative if one is negative and the other one is positive. And that line is not a good representation of what's happening there. Oh, that's a bit better. Okay, that looks a bit better. So how does something result in something being negative? Okay? For a product of two things, the resulting to be a negative, one must be positive and one must be negative, or one must be negative and the other one must be positive. Okay? So if you look at f of x is always positive. So f of x being negative will never happen. Okay? So as we said, f of x is always positive. So in other words, we're only going to look where the inverse function is negative. Look at it again. F of x is always positive, as you can see here. Why? What makes it positive? It's above the x-axis. It's positive. But below the x-axis, of course, is going to be negative. As you see, the whole graph is above the x-axis, which makes the whole graph positive. So f of x is always positive. Okay? So in other words, we're just going to look where the inverse function is negative. So as you can see, the inverse function is negative from there up until the point of 1. Beyond 1, the graph is going to be positive, as you can see there, or above the x-axis. So, for it to be negative, it will be between 0 and 1. It's a continuous solution. So x is greater than 0, but less than 1. Remember now they ask for equal as well. So, is the graph, can you put equal at 0? No. The graph will never be equal to 0 because the sum of the graph is, a graph of inverse function of f has an asymptote at x equal to 0, or the y-intercept. So it will never be equal at 0. However, can it be equal at 1? Yes, because a 1 gives us a 0 out. So our solution is x has to be greater than 0 and less than or equal to 1 there. Alright, so for homework, I want you guys to do exercise 3. Exercise 3, number 1. Okay, there are 4 sums there. You don't have to do number 2. Okay? So exercise 3, number 1, says 1.1 to 1.4, and that is on page 54. Enjoy the rest of your day and your weekend.